Okay, so just a bit of background. So just a bit of background. Because of the things that Web3 offers, like security and censorship resistance, it also has some limitations like scalability. Um, and also processing time, slow processing time because of how many nodes have to be processing tech transactions. So scalability is usually a problem. A bit of just background information for those of us who don't know what blockchain is. But for those of us who understand what blockchain is, you can just wait to the next slide. Let's just create a level ground for everyone. So on a normal web application would be interacting from a browser and then connecting to a central server. So the central server will normally have like a front end written in any of these languages, a back end, and a database. So everything is centralized. If you need to talk to the server, it would be in a central place. But for blockchains, it's a group of nodes all connected together with the same data, the same information, sharing the same information, validating transactions at the same time. So I would like to just use a bit of to demonstrate how we can scale blockchain nodes. I'm just creating a background so that everybody understands what the difference is in an environment where you have a Web2 application and a Web3 application. So to demonstrate how we can scale these nodes, a decentralized application node, I'm going to be taking an example app from University, an election application. Sorry, one. Okay, so just a bit of background about what this application is about. It's an election application, and it has a front-end client that is written in HTML, CSS, and JavaScript. The front-end displays the election results. The election is going to be about with two people, and instead of the back-end, the front-end will talk directly to an Ethereum blockchain, a local one. I'm going to be using Ganesh for test. And the rules of this election will be written in a smart contract. Is written with Solidity, and it will deploy the smart contracts on an Ethereum blockchain, and it's going to allow applications or users to start voting. Just if you want to get the source code, I got it from University. They have like a lot of trainings on how to build decentralized applications on Ethereum and other networks. So this is just a bit of architecture of how this application is going to run. So this is the UI of the election results. For every time a vote is validated, the count increments. And this is what the list of tools that the application is built on. So I already said the front end is built with HTML, CSS, and JavaScript. We have Solidity for the smart contracts. The package manager is npm, and a truffle network that is used for building and testing and deploying the app on Ethereum. Ganesh is the local in memory, so it has like fake ether for validating transactions. And then MetaMask. MetaMask is a browser extension that you can use to run it if you're running locally. That's the source. Okay, so let's deploy this decentralized application. Let's put it up so that it can run efficiently and scale. Sorry. Okay, so this is the architecture. I don't know if it's clear for everyone. I just try to. It's not, right? Okay, so what we can do is maybe later everyone can have like this architecture. But let me explain. So the developer pushes to GitHub, and when the application is pushed to GitHub, it triggers the build. Docker is used to build the application image, and it's pushed to ECR. Once it's pushed to ECR, Argo CD, which is a GitOps application, pushes and deploys the application on the node. Here, for the IAC, I use Terraform to build all the ECR rule to deploy the S3. I use S3 as backend for the TF files, and for the EKS also I use Terraform. So we also have Docker, this ECR, where the Docker image is deployed and then is pulled and deployed on the nodes. We also added an alerting system. So when the application is deployed, if there is let's say the node completes sync, we get a notification on Slack. And then if there is incomplete sync, there is unhealthy nodes, we also get notification on Slack. Kubernetes provides that notification component for you to add notification to the application. Okay, also please, I've added a repo where you can get the source code. So everything completely built, the deployment files from A to Z is actually in this repository. So I've added a link to it. You can quickly, it's my GitHub repository. The name is Learn with Osinachi. Is exercise 13. So you can I already built that up there. For the repo organization, I put both the infra deployment files and the application deployment files on the same repo. This is just because it's a dev environment. For productions, please try to separate your infras from your infra deployment repo from the app repo. Then next, okay, so this is the file structure. Can you see this, please? Is this clear? Good. So for the file structure, this is what it looks like. I have workflows that deploys S3, it deploys Kubernetes, it deploys infra and the alert, and also deploys it builds the DApp. So when the developer makes a change to the application, in this folder, it triggers a build workflow that builds the image of the application and pushes it to ECR. So that's just an explanation of all that is contained in the folder. Please, again, in the repository, you'll see, if you open each of the folder, you see all the contents. You see the YAML files for the Kubernetes and also see the TF files for each of the Terraform. Here is a Docker file that gives an instruction of what the base image should be to build the application. Now, let's get to the deployment steps. So why I added this is where you would fight bugs and fail and cry and come back and sleep and wake up. So it's at this point. Sorry guys. Yep, so for the IAC, after everything, I created a bucket for the backend. So all my state files goes to an S3 bucket, and that's the TF file for it. This is the ECR. Okay, no, this is the bucket that contains the TF files. This is the repository. Once the build completed, this is the repository. And then this, the EKS. So I just took screenshots of each of them on the console so that you see the successful build and what it has. This is the content of the infra file. So I have the backend file. There's an Argo CD. I deployed Argo CD using Helm chat. So there's a Helm release feature on Terraform. I used to deploy Argo CD. It made it very easy. And then the backend, as I said, that's S3. ECR for my image. The EKS, that's where the cluster is residing, and then the IAM for all the permissions that will allow the EKS to access the image, and then the nodes. So these are in the nodes, that's where you add the instance type and the instance size. This is where you define how your nodes scale. And then this where my output file is. This one's contain this Terraform TF contains the providers I used, Helm, Kubernetes, and the rest. These are the variables, and then that's the VPC. So if you clone this repository that has this, all you need to change are your variables, and then you change the secrets on the action. So in your GitHub action, you just put your own secrets, and then it should just go. I'll leave my contact if you have a problem trying out these deployments. Feel free. Next, okay, so DApp containerization. So here is where the Docker file works. Once there is a change, maybe there is a version of the application that the developer changes. There's something, just a change, and the developer pushes it to the repository. It triggers the build. So the build just builds a new image of that application and pushes it to ECR. If you check in the repository as well, you see the YAML file that builds and all the build steps. This is the image after it's completely pushed. And okay, so this is just the Docker file. So the base image is node, and then created a directory in the app, and these are all the steps. So here you see that we use TOEFL to compile the application. So once the application is once the application files are copied, TOEFL is what we use to compile the application. Then the ports are opened. Okay, so I think I skipped one slide. 1 minute, guys. Okay, sorry. Yep. So here are the Kubernetes files. The deployment. This is the YAML. We need the YAML. As I said, YAML is a local Ethereum node. It has Ether, but they are fake Ether. So every Ganesh has like 10 Ethereum, and each of them will give you at least to test your deployment or test the voting app. Then this is the namespace for the application. This is the service, the YAML file for the application. I just had to like provide this because this is just the only part in the workflow that is really important. The other ones are just your authentication to AWS and the other steps. So these are the only 2 steps. This one uses kubeconfig to deploy Ganesh, and then also uses kubectl to deploy the election application. That's the image from ECR. So it pulls the image from ECR and deploys it there. Now, as I said, I added alert. So I added like a simple alert. Thanks to Kubernetes, we have Argo CD notifications. So Argo CD can notify Slack in your work environment. It depends on whatever tool you guys use. If you use like Teams, but in this case I used Slack. So this is the configuration for the alert. So the alert has so if there is a deployment on Slack, you get an alert in the team group, like in a general group. Or if there's a failed deployment, if there is general health degradation on for the application, it will give you an alert, and then whoever is on call at the moment will just check that out. And also if there's a sync succeed, you also get an alert. So this is the Argo CD application, and these are the annotations I added for the alert. Then for the Argo CD, I had to add this because this is really important. You need the Slack secret. Slack has token that you need to, and then you can't push that to a public repo, and I didn't want to add it as secret to the workflow. So what I did was just to add the command to the workflow, and then just add the token as git action secret. Then it just pulls it and deploys it. In that way, we don't have a record of the secrets in GitHub. Then this is Argo CD configuration. It just everything that I configured here, the config map. You just need like three files: the secrets, the application itself, This will deploy Argo CD directly and also add the annotation for the alert. Then there's the workflow. I added a different workflow for alerting. Once it's complete, you have to check your deployment. So now this is where you run all the checking. Is your node running? Is everything synced? So let's go next to check. Okay, so here are some validation checks. No, I think I skipped one. Okay, sorry. Okay, so here are some validation checks. You check if your namespace is the pods for Ganesh and the app. Can you guys hear me? Okay. The app pod is up, so you just run this kubectl commands on your command line. Before these commands run without error, you would have validated your identification on your command line. So that means you check, you have to validate to AWS to be able to connect this, and then you also add kubectl kubeconfig locally to connect to the cluster. So for the election app, you run these commands just to check if the services and the pods are up and running. All the pods and services should be in a running state. If not, you have to go to bed unhappy. And then Argo CD pod as well. After everything, the Argo CD deployed, the application deployed on Argo CD. This is what your Argo CD environment should look like. Everything should be healthy, synced, and there should be no error. Before you get to this point, you would have fought unknown battles. So this is where your success is. Then these are more validations. You check your alert deployment if it's working. If your alert is properly set up, then your triggers should be able to send notifications to Slack. So this is just a test I did locally just to check. And then for Ganesh connectivity, you check your port forwarding. You should get a result like this. Ganesh should be forwarding properly. You check your Ethereum balance because you are going to test locally on Ganesh. We're checking if our balance is accurate. So this should display your accounts. These are 10 accounts and there are fake ethers there that helps you. And then of course you check the front end display. Your application has to display the front end. So this is the load balancer URL, and then it should display the UI. Sorry. So takeaway, in summary, we've set up a full CI/CD system that builds and deploys a DApp on Kubernetes with GitOps, that's Argo CD, and then alerting, that's our notification on Slack. So your app, once you test this deployment, should be able to load the front end. You don't need a DNS name because you're just using load balancer, so you can use your load balancer URL. You can connect to Ganesh, that means the port should be able to forward. You can load your election data from the smart contract on Ganesh, and then the users should be able to vote using Ganesh. So locally you should be able to test that you're able to vote, and then the results should update on the UI. So for each person that receives a vote, each contestant that receives a vote, there should be an increment. I chose to use this application for this talk is because most of us that stay in Nigeria, we know that elections are one of the things that we're talking about, and I just wanted to show how it's easy for a government that is serious to be able to build an application and manage it, and everybody can stay in their house and vote, and their vote will count. The nodes will not be changed because all of us will be connected to the node, and we will validate each vote that comes. It's really easy. So all we just need is someone to build a very good decentralized application front end. Thank you. And then DevOps engineers will deploy. We have a lot of them, and we'll all monitor. We'll add ourselves to a Slack group, and we'll monitor application from wherever we are. If any node is down, we have somebody checking it out. So it's just very easy if we really want to work. My closing remark. So I took a tweet from someone I respect so much, Jerry UK. He made this tweet a couple of days ago. He says that all the OGs within the space have similar stories. Not one of them will tell you they had flexibility. So it's not an easy road. You must be ready to do the hard things. So this is my closing remark for each of us. Thank you. Thank you, guys. That's my Twitter handle. And please, when you're checking the repository that has the application and all the deployment files, please give it a star if you don't mind. Thank you, guys.
Thank you so much. Clap, 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 clap. Thank you so much.